Hi everyone, it's Ciara with Aixterior here, and today I'm back showing you how to render an asset with Blender cycles again, but this time with our LOD and normals workflow. Let's get started. Okay, so the first thing we're going to do is go to the Aixterior website, and as you can see I've already logged in here, and I'm going to go to the browse page and then to My Assets to pick out the asset that we've already bought and downloaded. So you might remember this if you watched the previous tutorial, but last time I set up our custom download settings to have displacement workflow appropriate download settings. This time, however, I want to use my LOD workflow instead. So by default, it's already selected LODs for me here, but I don't need my ambient occlusion in this case, and I also want my normal LODs, so that's perfect. And I don't need my displacement this time, and I'm also not going to use these previews, so that looks good. And then I'm just going to press pack and download again, and it's packing now. Okay, so it's started downloading now, great. I already have my HDR downloaded since last time, so I'm not going to bother downloading that again. So we just have to wait for this download to be ready, and then we can start off in Blender. My download is finished now. I can open this folder. That worked, and now I don't need the website anymore, so I can close this. So here we are back to Blender. We have our folder with assets that have successfully downloaded here, so we just have to import these. In order to do that, I'm just going to clear the scene of the cube, go to File, Import, and to FBX, and then copy my file path and paste it in here. For the sake of demonstration, I'm going to load in several LOD levels and give you an example of how they work and just explain a little bit about what it actually means for those of you who may be unfamiliar. So I'm going to load in LOD level 0, which would be the highest, and then import LOD level 5, which is in this case the lowest. I'm pressing 7 on my numpad and then pressing G for grab and X to lock it onto the X-axis. And then I'm going to import LOD level 3 so we get a nice compromise. And now I'm going to explain a little bit about how LOD levels work. So if I go to my overlays here and then turn on our wireframe, you can immediately see that these assets all have different poly densities. So this is in essence the idea of an LOD, which is that you have assets that are loaded in to the same place, same orientation in the world and everything, but that they have various levels of detail, which is what LOD stands for, that then allows the game engine to not have to stream as much memory at once. So the idea is that you set a certain distance to the player camera, and at the furthest distance, in this case, you would have the LOD level 5, and then the closest distance you would have LOD level 0 or even higher depending on what you need in your real-time engine. And in addition to this, in order to make sure that the LOD level 5 does not actually look different to the LOD level 0, we can use normal maps to fake a lot of the detail that is being lost by transferring the high-res detail coming from the LOD 0 or even higher onto the LOD level 5. So let me show you that real quick. Okay, so for the sake of demonstration, I'm after creating materials for each of these LOD levels with the relevant normal assigned to it. I'm going to go into detail about how to set up the materials for this asset later on in this tutorial, but this is just for the sake of demonstrating what LOD levels can actually do. So if I go into our rendering here and turn off our wireframe overlay and then grab my point light by pressing G to move it. Okay, so what you can see here is that we've got this nice fine detail going on. You can see all this wood grain happening. You can see like little details on the bark, ground detail, all that kind of stuff. Now let's go to our LOD level 5, take our point light with us. You can see that although the geometry is harsher and we have some shading artifacts here that can definitely be fixed, but there is a lot of this fine detail that's still there. It's still being transferred. So the idea of a LOD level would be that regardless of the poly count, if I just turn on the wireframe again, regardless of the poly count of these assets, the detail level is still the same. You're just basically giving the real-time rendering engine a little bit easier of a time with regards to the capacity that it has to be running at in order to store all of this data. So that is what we aim to be able to facilitate for real-time engines. Okay, but all that aside, now I can just go back to my normal flat shaded view. I can turn off my wireframe and I can delete these because I don't need them anymore. And now I can start shading this asset. First thing I can do is set up a workspace for us. So I'm just pressing this little plus icon that you can get by dragging on the corners here. And what I want to do here is set up a camera view. So I can either toggle the camera view here, but you can also see that there's this shortcut for the numpad by toggling 0. Then I can zoom in to my view here, and then by pressing N, which is toggling our menu, I'm going to go to view, and I'm going to select to lock the camera to view, press N again to close the menu, And now I can adjust my camera view. This is perfectly fine. This is just going to be our general 3D viewport, and I'm going to change this to our shader editor. So now we've got a nice comfortable workspace to work with. So now we're ready to start building the material for our trunk, but we want to create a nice lighting condition first. So I'm just going to go up to our object context here and change it to world. And by default, you can see here we've got this background, which is plugged into our world output. That's perfectly fine because that's what this gray background is, but we want to use a HDRI that we downloaded from the website. So I'm pressing Shift A to shortcut our search, and then I'm going for an environment texture. And now I'm going to find the file path for my HDRI. So I've located my HDRI file path, I'm pasting it in there, and you can see that the color space has automatically changed to linear, which is perfect. We are using an EXR, so that is necessary in this case. And I'm just going to plug that into our background here. And if we go to our render settings, we should be able to see a change already. There we go. So that's actually already done something. Note that in this case, it does show up in Eevee as well, but we want to use cycles. And this is also automatically going to change. We're just using cycles because it's going to give us a little bit of a prettier result. I'm also going to change this to be a GPU computation because my GPU on my machine is strong enough, but this is completely dependent on the possibilities of your computer. So we've got our HDRI, but now that we may want to change the look of it or the direction of the lighting, we have to be able to rotate it. So I'm going to press Shift A and find our mapping node. And I'm going to plug this into our vector input here. It's looking a bit crazy now, but that's okay because it needs coordinates. I'm going to press Shift A again and go texture coordinate. And now I'm going to plug the generated coordinate into the vector and then you can already see that it's updated, but I'm going to change it to say 90 just to show that it is going to move it around. And yeah, that works. I'm going to change the lighting back because I think this is a little bit too direct for my taste. And we can always tweak that a little bit later when we've got our material set up. But for now, we've got a nice functioning HDRI, which is going to make our asset look a lot more realistic. So with that, we're ready to start setting up our asset material. I'm going to go from our world to the object context again and click on our asset and then go down to materials and press new here. Before I do anything else, I'm just going to name this material and I'm just going to copy the name of the asset that we already have. By default, you can see here that we've got this principled BSDF shader with cycles, and that's actually perfectly fine because that's what we need anyway. So the first thing I can do is bring in our normal map. So this is important to pay attention to just because with our LODs, we've got different normal maps for the different LODs because they are correlating to different densities of polygons and different resolutions and so on. So in this case, because I'm using the LOD 0, I'm going to use our LOD 0 normal map. Just going to drop that in there. And with Blender, you need to basically help cycles out a little bit to make it understand that it's using a normal map. So I'm just going to search for the normal map node here and then make sure that your color space here is set to non-color data because normal maps are encoding vectors and not values or color data. So if you don't change this to non-color, you're going to get some very off looking normals. But that's fixed now, so I'm just going to plug it in here and then plug those in to that. We can't see as much of a difference here, so I'm going to change the base color to be a mid-gray. That's going to make it a little bit easier for us to see these subtle details. I'm just going to zoom in. And yeah, here you can see we've got these nice little bark patterns going on. All that kind of nice subtle details. So that's looking nice. And we can now proceed with the rest of our maps. So the next thing I actually want is my color. I'm just going to take our albedo map that we downloaded and again drag and drop it into the scene and connect it up to our base color here. Cool, that looks good. Something that we can do to help out this render, because it's looking a little bit undefined right now, a little bit muddy, we can go to our render settings here and then go all the way down to color management and change the look to be medium high contrast. As you can see, that's just bringing out the shadows a little bit more. It's more of a transform that is being applied to the renderer camera rather than an actual change to the material itself. And this is just however you like it. It's up to you, whatever kind of look you're going for. But I think just to make this a little bit easier on the eyes, a little bit more aesthetically pleasing, this looks cool. So the next thing I want to get into is subsurface scattering. This is something that some people may be familiar with already, and it's also something that we went over in the last tutorial already, so I'm not going to go into it in as much detail. But essentially the concept is that subsurface scattering is where light hits the surface of an object and bounces around inside, creating this soft diffusion of light. This happens with things like skin, wax, any type of substance that has organic properties usually. And in this case, we've got a lot of vegetation on this asset. So you can see these like green patches here and on the ground and everything. So we've got moss and grasses and stuff like that. And it's really going to help the look of our asset if we add some subsurface scattering in there. I can already just pull up this slider here. As you can see, it looks interesting. Looks a bit weird, but that's okay. If I plug our diffuse map into the subsurface color, you can already see that it looks a little bit less strange, but we've got this weird orange tint going on. That's because our subsurface radius here, if we click the drop down, is not normalized, so the values are not all the same. So we can already fix that by pressing Shift A and getting ourselves a value node. It's to 0.5 by default, that's fine. Just gonna plug that in there. And you can see now this weird orange tint is gone. But the problem remains that now we've basically told the shader that this whole object should receive subsurface scattering, when in fact we actually just want isolated areas that receive subsurface scattering because the whole object is not made of moss or grass or this organic material. Well, technically it is because it's wood, but you get my point. So Aixterior actually has a mask that allows you to do this. It's called a vegetation map. And essentially this is just a black and white map that tells you white is where vegetation is and black is where there's no vegetation. So we can use this as a mask for our shader to tell it exactly where to apply subsurface scattering. So I'm going to show you how to set that up. In order to tell Blender what it should be shading with subsurface scattering and what it should not be shading with subsurface scattering, we need to create another principal BSDF node. And this one is going to be controlling the wood parts or the parts that should not receive subsurface scattering. So I'm now going to create a mix shader, and that is going to be able to mix these two shaders together. I'm going to plug that into our surface output and then put this into shader, this shader, and then the other one into that shader. And I'm going to change the base color of this one to a bright orange. So you can see that it's working. And now I'm going to pull up our vegetation map that I showed you before and drop that into our editor. And if we look closer at the mix shader here, we've got this factor slider. And that is basically dictating the factor at which the shader is mixing these two inputs together. So we can use our mask to drive this, if I just plug it in here. So now you can see orange where there is no vegetation and the diffuse map is showing through where there is vegetation. So perfect. So if we now plug this albedo into our base color instead, you can see that there is a little bit of a change in how this is looking. You can see that this is looking slightly softer than this area, but let's bring this out a little bit more. First thing we can do is dial down the specular to 0. This is a very easy way to simulate what is happening on a much more complex level in reality, which is where light is getting trapped inside of all of these tiny little strands of vegetation, and therefore it looks darker to the human eye. So this is just a cheap way to do that. And we're not going to apply roughness to those areas for the same reason, but we are going to bring in our roughness map for the wood shader. So I'm going to drop that in here. And again, drawing your attention to the color space, we want to make sure that our roughness is set to linear because it is storing values and not colors. So that's important. And we're going to plug that into our roughness output. And that is already helping make the surface feel a little bit more solid and a little bit more crisp. We can also bring this value down to be 0.2 instead. It's a little bit less soft. So the last thing that I forgot to do is to plug our normal map into the wood shader as well, so that we get our normals on both parts of the asset. And with that, we essentially have our very basic setup for our material, but as you can see, it's already looking quite nice and quite convincing. I'm going to just adjust our camera angle a little bit here and then kick off our render. Okay, so as you can see, I just changed our camera position, changed our HDRI position to make something that I feel looks a little bit nicer, and now I'm ready to go up to render and then press render image. Okay, so there we have our finished rendered asset to be used in your game environment or real-time environment or however you may like. I hope you found this tutorial helpful and hopefully see you next time. Bye!